Good evening all. Today we will discuss about hyperconjugation. Resonance involves delocalization of pi electrons leaving the sigma bond behind. However, in some cases a sigma bond and an adjacent pi bond may get involved in resonance. Such a delocalization is called hyperconjugation. When carbon possessing at least one hydrogen is attached to another carbon bearing an unshared orbital or to an unsaturated carbon, there are more than one structure possible for the molecule. These results from the overlap of the bonding electrons of carbon and hydrogen sigma bond with 2p or pi orbital of the adjacent carbon atom. As a result, the bond between carbon and hydrogen does not exist anymore. The shared pair of electron is now borne by carbon alone and hydrogen is in its close proximity as proton. The negative charge developed on the carbon gets delocalized by overlap with adjacent p orbital. Hyperconjugation, also known as no bond resonance. The electrons of the sigma bond between carbon and hydrogen involved in delocalization. In structure to the right, no bond between carbon and hydrogen due to migration of the sigma bond. Hence, hyperconjugation is also known as no bond resonance. This does not indicate that hydrogen is completely detached from this structure, but some degree of ionic character in the carbon hydrogen bond and some single bond character between the carbon carbon double bond. Such an interaction is also referred to as heterovalent or sacrificial hyperconjugation. This is so named because the contributing structure contains 1 2 electron bond less than the normal Lewis formula of the compound. At present, there is no evidence of sacrificial hyperconjugation with neutral hydrocarbons. Effect of hyperconjugation on the chemical properties, alkyl cations and their relative stability. Carbocations have an electron deficient carbon. The empty p orbital of the sp2 carbon can overlap with the sigma orbital of carbon hydrogen bond of adjacent alkyl group. This overlap permits individual electrons to help bind together in three nucleus, two of carbon and one hydrogen. The positive charge thus gets dispersed over large volume of space and is stabilized. The more the number of alkyl groups of the carbocation, more is the number of alpha carbon and hydrogen sigma bonds, and hence more are the possibilities for hyperconjugation, which makes the carbocation more stable. Here we can see that the order of stability of the carbocation is 3 alkyl carbocation is more stable than 2 alkyl carbocation is more stable than 1 alkyl carbocation is more stable than methyl carbocation. Alkenes and their stability. Overlap of the sigma orbital of carbon hydrogen bond with sigma orbital of pi orbital of adjacent carbon-carbon double bond gives rise to canonical structures. Delocalization of electrons occurs over the three nuclei and stabilizes the alkene. Alpha carbon hydrogen bond possess partial ionic character and its electrons get delocalized into the adjacent pi system. More the substituent, more is the opportunity for the hyperconjugation and more is the stability of alkene. Stability of alkene will increase with the increase in number of hydrogen alpha to unsaturated system. Other types of hyperconjugation, occasionally electron density will be donated from the filled pi or p orbital into an adjacent sigma star orbital. This is known as negative hyperconjugation. Other times, electron density will be donated from a p orbital into an adjacent pi star orbital. The result is an overall neutral charge on the molecule. This is also known as neutral hyperconjugation. Hope you like it. Thank you.